So here's this last one. We've got a function given by this, and they want to know where it has a relative maximum. So what you could do either the first derivative or the second derivative test. It's totally up to you. I think I'll just do the first derivative test. So the second derivative test, but that might be nice too. Okay, so well, we got to take the first derivative no matter what. So let me see how I feel. So we've got to take the derivative. As soon as you hear relative max, relative min, max or min actually, take the derivative. Because even if you're using the candidates test, for absolute extrema, you'd want the derivative. Okay, so that is f prime. Let me think. Okay, well, I mean, I gotta, actually, yes, this might be faster. Okay, so I'm gonna go f double prime now. I didn't do this initially. This is 60x cubed minus 24x. Okay, now I gotta find the critical numbers of this. Okay, so I gotta factor. So this is, I'm taking out a 3. 5x to the 4. Okay. Then two numbers that multiply to make -5 and add to make -4. Negative 5x squared plus 1x squared. So I'm taking out a 5x squared, x squared minus 1 plus 1, x squared minus 1. Okay, so 3, 5x squared plus 1, x squared minus 1, but then that one factors further. Okay, now guys, setting these equal to 0, 3 is never equal to 0. This one right here, if you go 5x squared plus 1 equals 0, that's actually going to give you x squared is -1/5. You can't take the square root of a negative. Okay, so this is not going to give you a 0. This factor happens to be always positive. So we're just going to get our critical numbers from there. Okay, so critical numbers are positive and -1. Yeah, I'm glad we did this. Okay, positive and -1 are both choices. Now, all that this tells us right here is that our graph has horizontal tangents at positive and -1, but we don't know if the graph is concave up or concave down. All right, so if it were concave down with a horizontal tangent, we'd have a max. If it were concave up with a horizontal tangent, we'd have a min. So we're looking for this max situation. So how do you know if the graph is concave up or concave down? You plug these into the second derivative. All right, so f double prime of 1 is 60 minus 24. All right, whatever that is, it doesn't actually matter. That's greater than 0. Okay, so this would mean concave up. So it must be -1. Let me just verify. F double prime of -1, that would be -60 plus 24. That's less than 0. Okay, so -1 is what's going to give us concave down.